circuit and what relationships exist.
I see a series circuit and a parallel circuit.
Yes, and they're combined in one.
Yes.
And if I ask the question overall, if you add up all the resistances overall, would this be a series or a parallel circuit if you've added up all the resistances?
I think it will be parallel
Why do you say that?
because there's more resistance on the parallel.
Um, that doesn't determine because remember you want to simplify the circuit because last year, if you remember, circuits were really simple last year. So
Yes, sir.
you can see we have an ammeter, we have a voltmeter, we have an open switch, we have a resistor. So what happens here is you have an invisible resistor here, and that resistor will be the sum because you're going to add the series, and then after adding the two top ones that are in series, you're going to add them with the one parallel at the bottom. Then you're going to get one unified resistance, and then that'll determine the basic structure of your circuit. So that's what I mean when I say the overall circuit. It's um after you've simplified and found all of the resistances. Does that make sense?
Yes,
So now, um, the next question I'm going to ask you is, what is the difference between a series and a parallel circuit as it pertains to um voltage and current. So in parallel, what happens? In series, what happens? What happens to the voltage and the current?
so in parallel the voltages are all the same, and in
Okay.
series like you plus them up.
In series, you what?
In series you plus them up like to get the total.
Yes. So in parallel, the voltage is the same. And in series, you have to add them up. Then what else?
Then the current in parallel is all the same as well. Then in series you have to plus it up.
Um, almost correct. Almost, almost correct. Try again. You're almost correct. You just made a small error. Try again. You just switch them. They have to be mirror opposites, remember? They have to be mirror opposites. Here, the current has to be added. The current I has to be added. And then here, the voltage is the same. So the voltage will be the same. So let me quickly confirm that, but that's how you should memorize them. The voltage is the same, but let's just double check our facts because this determines how we solve the question because we'll make assumptions. We'll make assumptions and then that's why I first checked whether you understand this. Voltage and current in parallel. I'm just double checking my facts. Voltage in parallel. So they tell us here in a series, the current is the same. That's what I was trying to write here. Current the
Yes.
same. That's why I got a bit confused. I shouldn't have written voltage again. I should have already written voltage there on top. Here the current is the same, so we are on the right track. Current is the same. So now you have to memorize it in this way because as we solve the circuit, we'll make these assumptions. If you don't have these assumptions correctly, then you'll have a breakdown. Um, then resistance. So what happens to the resistance? As we add more resistors in a series circuit, what happens to the resistance?
It goes up.
So here we can say R, the resistance, is directly proportional to the total resistance. And then here we can say the total resistance is inversely proportional. So the more resistors I add, the more I decrease it. That's an inversely proportional relationship. So those are the three governing laws for circuits. So really can't mix them up because as you solve the question, um, these will make or break. Um, okay, so how do you define EMF? Define EMF in words.
EMF is the work done per unit charge by the source.
Yes, let me double check that. I'm gonna go down slowly because I'm good in calculations, but definitions, I feel like I've always put that um for the day before. That's not our EMF. So I'm sure you were shocked, but that's not our EMF. That's the induced. So your EMF is correct. That's the other EMF. Then how do you calculate the resistance between B and C? So you have a parallel, then you also have a series situation. So how do you find the total resistance from B to C?
Would I use those two that are parallel at the top? Oh,
How are you going to use them? Because you have to use the let's go down. You have to use which two formulae we have to use if we go down. Um, which which formula will you have to use in this section?
it's not R equals V over I.
For the total resistance, because they're asking about total resistance. They're asking for big R. Don't really use the EMF formula here, which is good. Um, what about these two? What can you tell me about these two formulas?
That one is for parallel, and that one is for the series.
Yes, and in this case you have six, six, and then you have another six. So how are you going to apply that formula to that situation? 6
I would
ohm.
use the parallel one.
Yes, but
And
you're gonna add those two at the top, right?
yes,
So you'll get 1 over R is 1
over
over
6.
12 plus 1 over 6. Then tell me what the value of R is. Do it on your side here. You have to invert and simplify. So first do this little calculator. Then you
Okay,
have
so
1 over R. You get an answer. Then you invert that answer. Quickly do it on your side and tell me what you get. Because practicing this will be important. Because you always have to invert your last R. Let me go back to the
yes,
question. Oh, it's right. It's quite close. It's the last one. You always have to invert your R because that's the resistance.
the answer is 4 ohms.
Um, okay, let me check. 1 over 12 plus 1 over 6. So remember those assumptions we made at the beginning, they will definitely come back. Um, Trying. Okay, it's definitely 4. Then, so that means, so now do you see what I meant by simplifying your circuit? Always try and simplify life for yourself. So now we can draw a much simplified circuit. So now we know we have an ammeter. So now we can decide on the identity of this circuit. Just click on the link again. Just drawing the full circuit in this 1 minute. We have a voltmeter, then we have our battery, and then we have one resistor. Do we have another resistor? So that means we have a series circuit. So it means the current will be the same. Do you agree with that?
Yes,
The
sir.
current will be the same in a series circuit. So simplifying your circuit does help because now we can make deductions. The current will be the same. That's R, and that's 4 ohms.